Assalamualaikum warahmatullahi wabarakatuh. Hello, my name is Ridwan, and today I would like to talk about what happened in this experiment. From the observation, it's difficult in jotting down the position of the line in A4 paper due to the shake of hand. We also use a smaller ring to obtain the center point of the tree line in order to increase the accuracy of the data collected. Friction also appear on the pulley and the thread. The weight of the ring and the thread assumed to be zero during the experiment. And the last, their error occurred throughout the experiment, which caused the inaccurate in the data recorded. And that's all from me. Thank you.
My name is Muhammad Hafiz bin Jamadi. I am one of the group members from Group 5. I want to talk about theory from this experiment. A very basic concept when dealing with forces is the idea of equilibrium or balance. In general, an object can be acted on several forces at the same time. A force is a vector quantity, which means that it has both a magnitude size and a direction associated with it. If the size and direction of the forces acting on an object are exactly balanced, then there is no net force acting on the object, and the object is said to be in equilibrium. Because there is no net force acting on an object in equilibrium, then from Newton's first law of motion, an object at rest will stay at rest, and an object in motion will stay in motion. In terms of Newton's law of motion, this is the expression by using mathematics as summation of F equal to 0. Summation of F is the vector sum from any direction of forces acting upon the body. When the body undergoes a system of forces, all of which are in the xy plane, the forces can count by separated into their components x and y, such as summation of fx equal to 0 and summation of fy equal to 0. The object will be stayed as in equilibrium when it is at rest, but more definitely it's supposed to be called as static equilibrium because static means at rest or stationary. The most common application involves the analysis of the forces acting upon a sign that is at rest. For example, consider the picture at the right that hangs on the wall. The picture is in state of equilibrium, and thus all the forces acting upon the picture must be balanced. That is, all horizontal components must add to 0 Newton and all vertical components must add to 0 Newtons. The leftward pull of cable A must balance the rightward pull of cable B, and the sum of the upward pull of cable A and the cable B must balance the weights of the sign.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zarif Irfan Meshariful Azhar, and today I will explain about the calculation of this experiment, which is equilibrium of forces. So, we go to the introduction first. As we know, calculation is the most important part in a complete report to obtain the objective of the experiment. And from this experiment, we need to determine whether the object is in equilibrium or not by finding the resultant forces in a parallelogram by using law of parallelogram. So, what we got from the experiment, we have two tables and we need to fill up the table with weight and angles. And for table 2, we need to find the sine theta 2 over sine theta 1 and also cos 1 over cos 2, and we need to draw a graph. We need to plot a graph of sine theta 2 over sine theta 1 versus force 1 over force 2. And for table 3, we need to use cosine rule to obtain the theta 1 and also sinus rule to determine theta 2. This is different from the table 2 because at table 2 we need to find the angle by using protractor. So from the slide show the cosine rule formula and also sine rule formula. Next, law of parallelogram of forces. So forces and angle will obtain from the table 2 and 3, and we need to resolve the force 1 and force 2 into the resultant axis to find the net forces. So I will give you one simple example about law of parallelogram. So this is the example. We have 150 Newton and also 200 Newton, and the angle is 30 degree. So the first step, we need to construct the parallelogram from the question, and after we got the parallelogram, we need to put the value of the side of parallelogram. And for the next step, we need to find the direction of resultant forces. So after we find the resultant forces and we have the angle that we needed, then we can use cosine rule to find the resultant forces, and we can use sine rule to find the angle of the resultant forces. So that's all for calculation.
I'm Tanesh here, my memory number CD190249. Today we'd like to talk about discussion. First question, discuss the graph obtained. Based on the graph that have been plotted and we get, I can conclude that the sin theta 2 over sin theta 1 is directly proportional to weight 1 over weight 2 equals to f1 over f2. Since the calculated and experimental value we get the same value, the graph also will get the same value. And the percentage difference is 0%, thus we can conclude that our experiment is going well. By using the linear equation, which is y equals to mx plus c, we can assume that f1 over f2 is y-axis and sin theta 2 over sin theta 1 is x-axis. We can get the gradient graph is 0.94 and the percentage error is 6%. So the next question is discuss the parallelogram diagram obtained. By using the scale of 2 cm per Newton and drawing the parallelogram of OACB, the length of OC is same based on the length of OA and OB. As the length of OA and OB increases, the length of OC also increases. Another factor that influences the length of OC is the value of weight 2. The value of weight 2 is increased as the length of OC will also increase. The angle between the resultant was also depends by the value of weight 2. Next, when the value of weight 2 increases, the angle theta 1 will increase, meanwhile the angle of theta 2 will decrease. The third question is, make a comparison between experimental and calculated result. Due to the experimental we have the same value with the calculated result, there is no comparison between both of the result. Furthermore, we get different percentage is total to 0%, which shows our experiment is doing very well.
Conclusion of this experiment, me, Zarif Irfan bin Sharif Al-Azhar, as the representative from group 5. So at the end of this experiment, we have strengthened our knowledge about equilibrium of force and also how to find net forces by applying law of parallelogram. So at the simplest word, the body is in equilibrium when the resultant is equal to 0. And then when all the forces act upon an object are balanced, then the object is in a state of equilibrium. That means that the upward forces is balanced to the downward forces, and also the leftward forces is balanced to the rightward forces. And so we also know that cosine and sinus rules can be used to determine the angle of resultant forces, and this experiment need to be conducted in a closed room to avoid any external forces that will affect the result of these experiments. And also reading of measurement need to be done repeatedly to get more accurate values. Thank you for your concern.